last video we were talking about anatomy and physiology. What is anatomy and physiology? What are the things that, well, make up the body? And what determines if we're living? Why aren't we just a huddled mass of tissue? Why is a virus not considered living? And one of the major things was because it was of homeostasis. You're trying to find a balance. You don't want too much acid, you don't want too little acid. You want the pH of your body to be just right, or you're going to have some issues. You don't want too hot, you don't want to be too hot or too cold. You don't want too little oxygen or too much oxygen. You got to try and find a balance. So I did in the slideshow, these are a couple of recordings here to follow these hyperlinks that get you to them. A little bit of an animation if you want, but really all it's saying is that you're really monitoring for outside and inside factors. So like for instance, you don't want, if it's too cold outside, it's being sensed from the outside. If you got your blood pH being too weird and ski-wampusy, then, well, that's an internal thing. Hopefully your blood's not on the outside, or we got issues. There's a couple of ways that we monitor homeostatic balances. One is you got some type of stimulus. Let's say it's cold outside, and it's really cold outside. So it comes along. It's a stimulus. It causes your neurons to go, oh, I should send a signal up to my brain, which is your control center. It goes up to your control center. Most of the time it goes to your hypothalamus. 99.9% of the time it goes to your hypothalamus. This is your pituitary gland. This is your hypothalamus up here. And it goes, interesting. Yes, we should do this. So it sends out a signal out to the effectors. Effectors is just a really fancy word of what's being told to do something to fix the issue. So for instance, in our cold, we're getting a signal out to our muscles saying, hey, start trembling. We know when you guys exercise, you generate heat. So hey, why not? That's a good way to combat cold. Once you get back up to like 98.6 degrees Fahrenheit, that's the temperature of your body, it should be at least, then it's going to say, okay, everything's hunky-dory. You're back to 98.6. We don't really need you to keep on warming up. We're back up to 98.6. There's no reason for us to go back down. Excellent. A positive feedback, another way to look at it really quick, there's a negative feedback loop. Feedback loop is kind of like you have a hammer tied up to a pulley system that can be pulled that says, pull me, and some curious guy goes, yes, I should go ahead and give it a pull. The pull is the stimulus. There's a processing that goes, yes, we should do something, and then there's a response. Whack. Because of that response, the guy gets whacked in the hammer with a hammer, and most likely he's not going to try and pull that string again. Now, there is something called a positive feedback. That is, a stimulus comes along, goes to the control center, and then an effector responds. And that whatever happens, the response actually stimulates it even further. A really very dramatic example of that, and one of the few examples actually. Positive feedback is probably the least common. Negative feedback is the most common form of feedback. Is the birthing process. The birthing process is a positive feedback loop. So what happens is a little bit of a hormone comes along called oxytocin. You don't need to know what oxytocin is now. Maybe before, yes. Oxytocin gets released, and it causes the uterus to contract. Well, baby's head starts pushing on the cervix. Cervix gets stretched. Not a comfortable feeling. But the cervix goes, I actually kind of liked that. And the signal comes up, goes up to the brain, saying, hey, cervix has been contracted, or has been stretched a little, do it again. And it does it again. and the uterus starts contracting again. Well, the contraction causes the cervix to get stretched a little more, pushed a little more. The cervix goes, I really, really like that. And it keeps on going. If some of you that are a little bit weirdly inclined as I am, I'm not saying that I'm one of these, definitely not, but this is sort of like a teleologically sadist-masochist relationship. Those of you that haven't taken psychology yet, sadist is somebody that likes to give pain. A masochist likes to take pain. And so a positive feedback loop. Sadist says, whack. Masochist goes, oh, do it again. And this birthing process, this keeps on going on and on until the cervix keeps on getting wider and wider, and the contractions get shorter and shorter, and that's why actually you can tell how close somebody is to birthing, depending on how quickly the contractions are coming along in between. And till finally, baby's born. And then there's nothing to give more stimulus. There's nothing to give more response. So the feedback loop has accomplished what it wants to do. And voila, c'est magnifique. All done. There's a lot of things that really, really want to throw us in homeostatic imbalance. But our body does a really good job at not letting it go in homeostatic imbalance. Unless your genetics don't like you, or maybe you're eating a little too much delicious hamburger or really fatty substances. And your body can't really keep up, and it just goes bad. Other things are like diseases. If they get into your blood, it's called sepsis, which really, really messes with you because that bacteria is trying to take up the resources and it's producing a lot more waste products, and it's bad. Meningitis is really, really bad, especially if it's E. coli. Anyway, sorry, that's FYI. With that is the basics of homeostasis. I would recommend being familiar with the negative feedback loop, positive feedback loop. What is homeostasis? What is the importance of homeostasis? And that is it for this one.